So we learned in the last section, if x represents the coordinate of a point on a number line, the absolute value of x is equal to 3, means that the point is exactly 3 units from 0 on the number line. So here's 0. So the solution x is 3 units away. So 1, 2, here's an x. And starting at 0, we can also go to the left, 1, 2, 3. And so we come up with two solutions. X could either be -3 or 3, and we'd write it like this, the set of -3 and 3. So what do you think the absolute value of x is less than 3 represents? Well, that means that the point is less than 3 units from 0 on a number line. So here's my 0. The spots that are less than 3 away would be any of these. I'm going to put little x's all across here. Any of these numbers would be less than 3. Now 3 itself is exactly 3, so it's not less than, but that's true to the right, and it's also going to be true to the left as well. So those are all, my x's can all fit in there as well. So you can kind of see a demonstration on a number line what solutions would work for the absolute value. The distance of x from 0 is less than 3 right there. So if we wanted to express that algebraically, we'd say that x is greater than -3 and at the same time less than +3. So x is in between -3 and 3. And you see that I'm going to start with the smallest number. There's the point, and then x is smaller than 3. So to solve an absolute value inequality where we have the absolute value of x is less than a, as long as a is positive, then the absolute value of x is less than a is equivalent to the negative of a is less than x is less than a. So remember from the past discussion that x can represent any expression that's inside of there. Also, the number line then would look like this, where we'd have the -a, here's +a, 0 is going to be in the middle, and it's going to be everything in between, so it's going to look like this. All right, so let's set this one up. So remembering our pattern, I've got the absolute value. This is my big X, is less than 2, and whatever's on the inside, so this expression, x minus 8, is going to be bigger than -2 and less than 2, and you want to start it in this way. So put the inside of your absolute value in between the negative and the positive. So then to solve this, I'm going to add 8 to all three sections, and I'm going to get that 6 is less than x is less than 10, and that would be my solution. If I had to graph it, it would look like 6, 10, open dots, and everything in between. All right, so before splitting apart an absolute value inequality, isolate first the absolute value on one side of the inequality. So here you see I have my absolute value, but I also have +6 here. So I want to undo this, and I want to subtract 6 from both sides, and that will leave me with the absolute value of 3x plus 2 is less than or equal to 7. All right, so once I get down to this point and I have an absolute value less than a number, a positive number, then I say that that inside is in between a -7 and a +7. So to solve it, I'm going to subtract 2 from each section and get -9 is less than 3x is less than 5. And then I'm going to divide everything by 3. And my result is going to be that -3 is less than x is less than 5/3. And again, on a number line, it would look like this here. So again, here in example 3, we're going to isolate So I'm going to subtract 9 from both sides, and I'll be left with the absolute value of 2x minus 3 over 4 is less than 5 minus 9 is negative 4. Now this is a special case because here my a is negative, it's not positive. So we need to think, when is the distance less than a negative? Well, remember, absolute values are always positive. So this is positive. So when is a positive number less than a negative number? Well, that never happens. So the solution to that is going to be no solution. So when your a over here is negative, it's going to be a special case.